So supply chains are the most geographically complicated thing on the planet. There's billions of node points across every continent on the planet. And so when I put together this panel, I wanted to bring that to this symposium. And these are the world's experts for the most part, in my opinion, my humble opinion. These are the best people who do like geospatial supply chain management. And I'll go ahead and let them introduce themselves. Again, I'm T. Barr. My day job is I'm a director of geospatial solutions at Verisk. We're the insurance company, and I'll let everybody else. Sadie?
Thanks so much. Great to be with you all today. Before I intro myself, I just want to say today is a geography day for me because I got my undergrad at UW in GIS, and tonight I'm actually speaking at returning as like an alumni of my program to talk about jobs in geospatial intelligence. So great to be a day packed with geography. I'm the CEO of a company called Enfourier. We are a predictive intelligence firm focused on global supply chains, but specifically on the transport and logistics network that connect everything that connects all of us to the products, goods, things that move us. We predict disruptions before they emerge for global companies around the world.
Okay, name is Alex Vengerovsky. I have a long-winded career in the United States. I came from Ukraine way back. Worked a lot in technology for financial companies. Spent a big chunk of my time with Dun & Bradstreet and Bridgewater Associates. And now, after meeting with my partner, Ken, we decided to spend our remaining energy on something which is really challenging, which is we started with building inventory of all physical assets, whether it's manufacturing, warehousing, airports, airstrips, hospital, universities, pipelines, and the list continues. It's basically barebone, foundation of our civilization, right? It's not a virtual stuff, it's something that you can touch. And once we build it, we started asking ourselves how we make products out of it. And one of the areas that we see a lot of traction right now is supply chain. And what makes that click is that there are a lot of information about, let's say, non-contextual information about the world where we live, such as satellite observations, traffic data, mobile traffic data, food traffic data, truck traffic data. But we do have context. We have information about assets on the ground, environments where these assets operate, what kind of people live around it, environmental conditions and everything. And by marrying these two sources, I think we can produce, and we produce some interesting insights. That was speech for my company. Thank you.
Hi, everyone. My name is Danny Sheehan. I cut my teeth here at the Department of Epidemiology as a geographer here at Columbia University. I've also worked at a couple startups, Cardo being maybe one, or what was CardoDB when I was there. Also pioneered on a team at UBS, Swiss bank, bringing geospatial to the equities research department there, kicking off a team called Evidence Lab. In addition to that, I've worked at Amazon Web Services as well as Jupyter Intelligence and Crosswalk Labs. Currently, I'm at Open Supply Hub doing data engineering and AI. I have some experience in supply chain, but I think there's some experts here. My particular skill set is mostly around data architecture, data engineering, and AI as well, using services like Bedrock. So I'm really excited to be here and grateful to be here, and nice to meet you all.
Thank you for the opportunity to join you today and for joining us. My name is Sara Rosner. I'm the Director of Responsible Investing Research at AllianceBernstein. We're an investment manager, so we manage about $860 billion on behalf of a range of clients from insurance companies and pension funds down to high net worth individuals and families. And our duty to those clients is to help them grow their assets and their capital. And I work with our investment teams to help them integrate material, environmental, and social issues into the investment process. I spend a lot of time on things like climate change, biodiversity, water risk, et cetera. I will also just disclose, in the spirit of full disclosure, that I am live learning about GeoAI as I'm sitting here and listening to everybody. So I'm absolutely delighted to have the opportunity to engage with you all. Thank you.
So let's get started with the free-for-all then. So open question, anyone can respond. If we think of future supply chains as living organisms, and GeoAI is a nervous system of those organisms, how close are we to a world where satellite, IoT sensors, and financial data are fused into a single adaptive supply chain intelligence? And what are we missing to make that real?
So I could take a quick stab at that. I mean, sort of the data, I don't know, is anyone here familiar with the term data mesh? So some of the CSPs, the cloud service providers, are really trying to pitch this idea of data mesh and really bringing all that data together and having a robust data governance and doing sort of the unfun and unsexy work of setting up data architecture and setting up that governance layer, I think is pretty critical to be able to join all that data together and then have it. There's a term at NOAA called analysis-ready data, or ARD, and really having that data analysis ready, but then also having it registered in something like a data mesh where folks can query that data and then have sort of the security protocols and access controls in place so that the right people are getting at the right data.
I can agreed, and I just want to say that I think when we're talking about geospatial systems and geospatial intelligence, there's a tendency to focus on satellite imagery and IoT systems and what Esri is doing and all of that. But when it comes to supply chain, and what we see a ton of is that the actual Kututniks that need to be worked out are oftentimes human to machine systems. So for instance, the understanding something as seemingly simple as when a vessel is considered at port is actually an incredibly complicated challenge that usually involves one single person entering something potentially incorrectly, into a system from 1986. So when I look at that question, I think about, yes, sort of the amazing power that we now have to monitor our world geospatially, but that it's, from my perspective, it's oftentimes the more human-driven error bars that you have to take into account when you think about having a unified view of both where things are, but then also how they move around, and then where things are going to be, and that kind of thing, which is such a core component to supply chain.
Actually, Dan stole my point, which I'm very frustrated. Look, I'm kind of, the question is what you eat. If you eat garbage, what do you expect to get? So analysis-ready data, yes. Definitely, I can just add my token to what you're saying. Absolutely, it's quite uninvested area, I would say. Now, in terms of actual question, satellites and what their roles, it's a huge role, but nothing is perfect. Satellite data, well, it's very expensive to hang satellite on top of particular site for 24 by 7 by 365. It's impossible from financial perspective. The quality of data varies. Sometimes they cannot see through clouds, sometimes they can. It really depends on quality of instruments. So it's a whole science in itself, but it's very, very important and instrumental. I think the answer is in combination, I call it synthetic view, at the problem. You need to take into account the satellite observations, the facts on the ground, what do you know about this place, what is happening, what kind of people live in there, what kind of industries exist in there, what their relationships with other industries, what kind of truck traffic, passenger traffic, other data sets could be attached to illuminate the problem. I think at the end of it, we go back to your point, is quality integration of good data. That's a key. Then you can apply artificial or human intelligence and may get something back. That's my kind of synthesis of that.
I can speak at a high level, I think, to the financial use case, which is, in our experience, a lot of these platforms, a lot of these models are not built for the for the investment decision maker, and we are a consumer of Evidence Lab. So I think I think that speaks to our own operationalization as a portfolio manager. Then there's the other level, which is what do we see in terms of what our portfolio companies are doing And we're very dependent on their disclosure. We today see very little disclosure on supply chains, and it's a growing area of interest for us for a number of reasons. And I'm speaking about broadly about, I think, most investors today. As we think about risks, as we think about opportunities, companies that monitor and are engaged in their supply chains have better traceability, better reputational risk management, better risk management overall, better cost efficiency. But it's often very challenging for us to get that perspective from what's out in the public domain. So we as an active manager, as opposed to a passive manager, are very focused on engaging with these portfolio companies over time to not only understand what they are doing, but what they could be doing in terms of best practice to manage their supply chains, whether that's strategy or even better disclosure. The disclosure piece is often tough because there's often competitive concerns there, which we understand, but I think we're always looking for that evidence. Companies that manage this part of their business are generally just better managed companies, period, better risk-adjusted returns that we can make on behalf of our clients.
Very good. So, Danny, Open Supply Hub is basically making a Rolodex for the global production of the planet. What's the biggest technical or political roadblock in turning open facility data into machine-readable, AI-ready infrastructure data?
Sure. So at Open Supply Hub, we've already actually implemented AI in some of our data moderation processes and saved several hundred hours, which for an organization of about 25 people is quite substantial. But let me break down the question a little bit to the different parts. So the techno-political challenge really, and I alluded to this earlier, is sort of the data governance layer or data issues, right? So data is fragmented. Sometimes it's in spreadsheets or different data platforms. Sometimes it's in a government registry. It's not necessarily interoperable. So what we do is we clean, harmonize, and conflate. The term conflation means sort of taking entities and finding duplicates or matches. And we use traditional ML like clustering and NLP. And more lately for conflation, we've been using for lower confidence matches using LangChain and Amazon Bedrock, which is a service that allows us to access all the different commercial models, LLM models for model access, and then getting structured output, right? So your LLMs traditionally just provide that free text. If you give it the instructions via the prompt to get structured output as JSON, it becomes a little bit more usable downstream. And then we use a consensus-based framework. So we ask the LLM or multiple LLMs multiple times. So in the case maybe 5 times we ask the same question, and in order to reduce the effect of hallucinations, we make sure that it has pure consensus. It gives us the same answer every time. Otherwise, fall back to the human expert in a loop. And we accept that our users are going to provide messy data and contribute messy data. So really building that architecture and infrastructure and systems to really harmonize and conflate that data. And so on AI-ready infrastructure, 2 important things: trust and traceability. So we want to log every decision to object storage. We want to store the reasoning output, and then have our inference close to the data and where our data exists, right? We don't want to be sending data across the wire. We want to have our models in a secure environment. So the CSPs set that up pretty well. And so setting all those things together, we have prompts and models and agents and all these things. They really draw a lot of the attention, but the real fuel is setting up the infrastructure, like vector databases or vector object storage, right? So those embeddings, and that really gives you the fuel to kind of move. And on the physical and transition climate risk side, you need accurate physical attributes for modeling physical risk, and then accurate activity data for emissions factors. And so again, the harmonization and conflation of data really allows you to do that. And then lastly, dynamic web content APIs or agents that search the web, they can verify and fill in your data gaps. So all these tools are really interesting. We still need to piece these things together. We still need to have our architecture in place. So I'm optimistic, but I also encourage folks to really stray away from the easy button and go towards agentic layers and things like that, and go towards actually spending the time to build out that infrastructure, because that's really the thing that's going to allow you prepare your infrastructure and your teams, and that's going to allow you to build that service layer to really scale with your AI ML for an enterprise, for example.
Excellent. Sadie, what you're doing is you're training models to anticipate disruption in supply chains across climate, conflict, and logistics. How do GI systems learn causality, not just correlation? And so they can actively forecast cascading events before they hit.
A great question. It's a tough question. I will say that my answer is going to be a lot less technical than the one that you just heard. I will not try to use the word APIs and conflation in a sentence, because just full disclosure, my co-founder is the technical one, the CTO. I'm just kind of a grunt who talks. But that being said, two things to start off with. The first one is that supply chains are, at least the logistics and transport networks, the stuff that moves around, is an incredibly complex and dynamic system. And so a lot of the traditional AI approaches that you'll see are taking, like static forecasts and like projecting forward into the future, using backwards historical information that these models are trained on. We're taking a much different approach. My co-founder likes to say it's an entirely new computational paradigm, and I say you can't say that to people. Their eyes will glaze over. But in many ways, he's correct. So we have a multi-pronged approach that basically blends simulation, digital twinning, agent-based modeling, and then actually physically constraining the system that we're looking at in the physics of the world and what the infrastructure actually does, which is a fancy way of saying that we have mapped the entire way that right now ocean freight and maritime trade flows work. Historically, we then interact that with live agent data, in this case, ship information. We use IoT and sensor data. And then we basically simulate how those agents interact with the constraints of the Earth to produce, you can think of it like a full distribution of plausible outcomes for those individual agents. So while that is not like direct causality, because of course weird shit happens, and no competent mathematician would ever say that they have completely mapped all possibility spaces, we are able to get to with a high degree of confidence to the actual ways that these individual vessels, in this case, but can be extended to trains and trucks given certain circumstances. You can actually get like a pretty good idea of how these agents behave in the real world. And we're so helped by this because the world, of course, is bounded. And so, when you actually look at the amount of data and information that's available, it's huge for sure. But, for instance, looking at things like the way that Panamax class vessels are built, these are massive vessels that transport a huge amount of goods every year around the globe. They're designed to fit within a couple of inches of a waterway that is subject to hydrological flows that we understand. Same thing with the inland, the Rhine River, and these critical waterways in Europe. We're actually doing some work right now with in the defense space, looking at particularly commodity flows in and out of Europe and how they might be impacted by drought or extreme rainfall, which is all a long-winded way of saying that, I'm not going to say that we're able to get directly at causality, but because we're working with these novel approaches in a physically constrained space, we can actually map distributions of outcomes pretty reliably and robustly.
Pretty good.
Yeah. No, I'm kind of dumbfounded, actually. I'm like, yeah.
Well, what my reaction is, in all the inputs that you take, the most valuable is set of constraints, in my view. That's the most valuable. It's a human thing.
It is.
And at some point, hopefully, AI will say, oh, I know this all, I know laws, physics, and I know how you people behave. But we have, I think, a long way. And until then, what you do is extremely, codifying that stuff into the model is extremely valuable.
Appreciate that. Yeah, constraints are good in this case, actually, when you're training models.
Yes. So Alex, at Spatial Risk Systems, you guys put risk stores at a building level. As foundational models ingest more imagery, mobility, and climate data, how do we keep GeoAI-driven risk scores transparent enough for auditors and regulators?
Let me go back before we go forward. So we started with this big database, we call it knowledge graph, and then we started asking how we're gonna basically create a product, and one seemed to be obvious choice was to start building some kind of risk metrics that based on this data, based on the weather data that we have attached to our knowledge graph, we can produce something. We did it. I did it, and I'm not impressed by that, to be honest, because at the end of the day, thank you. The end of the day, we all people who produce those risk scores looking back, most of them. And people who look forward, they look 15, 30, 50 years forward. And what people really need is sub-seasonal forecast, which is stuff that is happening between 2 and 52 weeks from now. And we cannot do it right now. I know only of one company which does it well. So since then, we moved to other interesting things in supply chain specifically. The problem that we're trying to build or solve is build a relationship matrix in focusing to start with manufacturing in the North America, US, Mexico, and Canada, and then go to Europe to understand all the relationships within manufacturing sector, which includes the intermediary like warehouses, distributors, ports, airports, and a bunch of other interesting things that allows us to understand the choke points and understand how those choke points may be impacted by different disrupting factors.
Good. So Sara, investors are increasingly demand spatially related ESG, spatially verified ESG. What would it take for geospatial intelligence to become a standard feed into a financial disclosure? So every facility's emissions, flood risk, climate risk, and labor exposures are integrated in the financial models.
This is a great question. I think maybe it would be helpful to step back and kind of unpack what we're thinking about when we think about ESG. In our view, evaluating material, environmental, and social issues can often lead to better outcomes for our clients in that these issues can have real material risks and opportunities for the companies that we invest in. And so when we think about geospatial data, when we think about GeoAI, I think what we're really thinking about are what are the issues that are really presenting headwinds or tailwinds to the companies that we're investing in. So climate change and biodiversity, migration, different types of health outcomes, resilience. These are all themes that are presenting live in real time material risk and sometimes opportunities to these businesses. So I think it's a dual layer process, right? On the one hand, we invest in companies because we believe in their management teams. But we also have to monitor those companies, and how we do that is through public disclosure, through things like SEC filings, earnings transcripts, all kinds of sources, sell-side research. And there's really no significant impetus today for companies to disclose a lot of locational information unless it is mandated because it's presenting something significant that investors should know about. So policy here is really, really important. I think also what we do see in terms of companies that are disclosing this type of information today or are really using GeoAI, these tend to be companies that are under the purview of jurisdictions that require this type of disclosure or this type of management in their supply chains. So think about agricultural companies, food and beverage companies. These are also companies that have been under significant investor pressure for a number of years to really manage this issue to their business. If you are a food and beverage company and you don't understand which parts of your supply chain are most exposed to water scarcity, that's a major issue for an investor. But it's also not uniformly disclosed. It's not required in a lot of jurisdictions where these companies, most jurisdictions where companies operate today. So I think that's one piece. The other piece I would just say, there are a lot of There are a lot of products on the market, I think, when it comes to data and research, really focused on providing this type of information to investors. And I know I have a colleague, Gillian Malode, who's, I think, going to present after this, who's absolutely fabulous. We went through a master's program here at Columbia together. And I think there's a lot of progress being made. But what I would say about those products and services is that they're only as good as the data that you're putting into them. So garbage in is garbage out. They don't make that data better. It doesn't make that disclosure better. So disclosure is really, really important.
Excellent. Well, they're about to play us off. So I appreciate everybody's time and your inputs and your expertise in this amazingly expanding geospatial world of supply chain. Thank you very much for attending.
Thank you.